And welcome to part 2 of 6.3. So let's do another example. We'll get through this one a little quicker than the previous one. Here's my hyperbola. I recognize that it's a hyperbola because of the minus. And like with the ellipse, we are equal to 1. So notice this time y squared is positive as opposed to the previous one where x squared was positive. So that means we know we're going to be opening up and down. So let's draw our little box. Y is up and down 5. Okay, y is up and down 5, and x is over and across 2, because you just take the square roots of those numbers. So in this case, a equals 5 and b equals 2. So you get that little box right there, so let's draw it in. Just like that. So there's our little box. The next thing we do after that is we draw our diagonal asymptotes through the corner of the box. And this way. Just like that. And remember that because we're opening up and down, these are our vertices. So we're opening up and we approach the asymptotes and down. And there's your graph. Just like that. So there's the graph of it. So you see it's pretty straightforward if you just make the box and draw in the asymptotes and then just fit the graph inside of the asymptotes. Okay, so once again, what is our center here? Our center is once again at 0, 0 because we don't have any h or k. The vertices, this time the vertices are on the y-axis, and so that's 1, 2, 3, 4, 5. So it's going to be 0, 5, and 0, negative 5. Those are our vertices. Let's do the foci last. Let's go ahead and do domain and range now. So let's do domain. Now this time, you see that the graph goes all the way to the left and all the way to the right. So since we're opening up and down, the domain is actually all real numbers because we go left and right forever. However, we see that vertically there's this stretch where there's no graph. So the range is going to have a gap in it, like the domain had a gap in the previous example. So again, that's negative 5 and 5. So it's going to go from negative infinity to negative 5, include negative 5, and then go from 5 to infinity, including 5 as well. So those are square brackets. So negative infinity to negative 5, union 5 to infinity. Let's do the asymptotes. Okay, and again, I just do rise over run from the box. So it's up 5 over 2 or down 5 over 2. So the asymptotes are y equals positive or negative 5 over 2x, because again, it's rise over run. Finally, let's calculate the foci, and we do that with the equation c squared equals a squared plus b squared. So c squared equals, let's see, it's just 25 plus 4, because that's a squared plus b squared. So c squared equals 29. C equals positive negative square root of 29. And now notice this time it's up and down here. So that means that the asymptotes are going to be as follows. They're going to be, we're not moving for x, so it's going to be 0, and then the square root of 29, and 0, negative square root of 29. Okay, because this time they're on the y-axis, so we have to put zeros in for x. And that's everything they asked for. We got everything. So hopefully this is starting to make sense. If you have any questions, make sure you leave it in the comments. Let's go ahead and do the next one. So the next one, you notice something's a little bit different. And the thing that's different this time is we're not equal to 1. So I kind of recognize that it's a hyperbola because it's x squared, y squared, and minus. But first we need to make this equal 1. So let's divide by 1764. Divide by 1764, divide by 1764. which is going to give us 1 equals, let's see how many times, if I do 1764 divided by 49, I know that's backwards, but I see that I get 36. So basically these cancel, and then this will turn into 49 because we just saw that it's 49 times 36. So this is going to become x squared over 49 minus y squared over 36. So essentially I just saved some time in reducing the fractions, because if I did 1764 divided by 36, I get 49. So that's just reducing these two fractions, and now we're ready to go. So I see that a is 7, b is 6, x is coming first, so we're opening left and right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then up and down 6. Okay, so there are my 4 points, kind of like with an ellipse. Let's draw our box. Just like that. And then after you've drawn the box, you just draw your diagonal asymptotes. And then we remember that because x squared, x is being squared, so we're going to open left, and we're going to open right, approaching those asymptotes. Just like that. So there's your graph. And remember, these should kind of be dotted lines because they're the asymptotes. This is the graph of the hyperbola. Okay, so let's just go through it real quick. Our center is 0, 0, because we don't have an h or a k. Let's do our vertices. This time they're on the x-axis as opposed to the y-axis, and they were at -7, 0, and 7, 0 are the two vertices. Let's do domain and range. We have a gap in our domain, so it's -infinity to -7 inclusive, or +7 to infinity. So our domain cuts out this gap from -7 to 7. But with the range, we go up and down forever. And so the range is all reals, all real numbers. Let's do our asymptotes. It's rise over run, and remember we went up 6 over 7. So the asymptotes should be y equals positive negative up 6 over 7. Make sure you don't get that confused. It should be up 6 and over 7. And then finally, let's calculate our foci, which are going to be on the x-axis somewhere. Those are just guesses. Let's find out where they are. And we do c squared equals a squared plus b squared. So a squared and b squared are 49 and 36. So if I do 49 plus 36, I'm going to get c squared equals 85. And then just take the square root. So c equals positive negative root 85. And so that's the distance from the center to the foci. So since they're on the x-axis, they are going to be at root 85, 0 and negative root 85, 0. And I believe that's everything. So we're making good progress. We're most of the way through 6.3. We're getting close to 10 minutes, so let's go ahead and stop here. We have a few more examples to do, and then we'll be done with this section. So hopefully after seeing a few of these, you're getting used to graphing hyperbolas. So I will see you in part 3.